Today we are going to learn about implementing rate limiting in microservices. We will explore various rate limiting strategies, understand their importance, and acquire the skills to apply these strategies effectively in a microservices architecture.
Welcome to our session on implementing rate limiting in microservices. Rate limiting is a crucial technique that controls the amount of incoming and outgoing traffic to or from a network. In a microservices architecture, where numerous services interact with each other, rate limiting helps in maintaining the reliability of the system by preventing abuse and ensuring fair usage. We will explore how rate limiting functions as a gatekeeper, protecting applications from being overwhelmed by excessive requests. By understanding these concepts, you'll be better equipped to manage service loads effectively and maintain system health.
Rate limiting algorithms are the backbone of implementing rate limits in microservices. Let's discuss some of the common algorithms used today. The token bucket algorithm allows tokens to accumulate over time, facilitating bursts of traffic while maintaining a steady state. The leaky bucket algorithm, on the other hand, processes requests at a consistent rate, smoothing out traffic spikes. The fixed window counter is simpler, counting requests in fixed time windows, but can lead to issues at window boundaries. The sliding window log provides a more granular approach by recording timestamps for each request. Choosing the right algorithm depends on your specific use case, such as whether you prioritize simplicity, granularity, or burst handling.
Selecting the appropriate rate limiting algorithm for your service is crucial for optimal performance. Start by evaluating your service needs. Are you dealing with consistent traffic or unpredictable bursts? Understand your traffic patterns by analyzing historical data. Consider latency and throughput requirements. For instance, if low latency is critical, simpler algorithms like fixed window might be preferable. Also, think about how adaptable the algorithm is to changes in service demand. Finally, balance the complexity of implementation with the efficiency provided. Simpler algorithms may be easier to implement but might not offer the level of control that more complex ones like the sliding window log provide. Client-side rate limiting involves implementing rate limits at the client level before requests reach the server. This technique is beneficial as it reduces the load on servers by controlling traffic at the source. Various techniques can be used, such as implementing rate limiting logic in SDKs or libraries that clients use to interact with your service. Real-world applications like APIs provided by companies often include client-side rate limits to ensure fair usage. However, it's essential to understand that client-side rate limiting complements server-side techniques rather than replacing them. Drawbacks include potential security risks if clients tamper with the implementation, and it requires cooperation from the client to be effective. Server-side rate limiting is a more common approach, where limits are enforced on the server handling the requests. This can be done in a centralized manner, often using a dedicated service or middleware that manages limits for all services, or in a decentralized fashion, where each service manages its own limits. Techniques include using reverse proxies or load balancers that can manage rate limits for incoming traffic. In microservices, it's crucial to handle rate limits for multiple endpoints and services, ensuring that each service is not individually overwhelmed. Integrating rate limiting with authentication systems can help enforce limits based on user or service identity, adding a layer of security and personalization.
In a distributed microservices architecture, implementing rate limiting presents unique challenges. Ensuring consistency across various services is crucial, as each service might have different rate limits. Network latency can also impact the effectiveness of rate limiting, as delayed requests might be counted incorrectly. Handling failover and redundancy is essential to maintaining service availability. Distributed systems should be designed to avoid single points of failure. Coordination across multiple nodes in the network is critical to ensuring that rate limits are applied uniformly, which can involve complex synchronization mechanisms. These challenges require thoughtful design and robust infrastructure support to implement effectively.
Monitoring and logging are critical components of rate limiting implementation. By keeping track of rate limit breaches, you can gain insights into how your services are being used and identify potential abuse patterns. Setting up alerts and notifications allows your team to respond quickly to any issues, minimizing downtime and maintaining service quality. Analyzing rate limit data over time helps identify trends and informs adjustments to the rate limiting strategy. Logs are invaluable for debugging purposes, providing detailed records of requests that exceeded limits. This information can be used to improve system resilience by adjusting algorithms and thresholds to better handle the observed traffic patterns. As your service grows, scaling your rate limiting strategy becomes necessary to handle increased traffic efficiently. Designing for scalability involves planning your architecture to support growing demand without significant rework. Implementing dynamic rate limiting can help by adjusting limits based on current load and system capacity. Leveraging cloud-native tools and services can simplify scaling, as many cloud providers offer built-in rate limiting solutions that are highly scalable. Optimizing for performance means ensuring that rate limiting does not become a bottleneck itself. Efficient algorithms and architectures are essential. Regularly reviewing and adjusting rate limits based on usage patterns ensures that your strategy remains effective as your service evolves.
Implementing rate limiting effectively requires practical knowledge and experience. By examining case studies and examples from companies that have successfully implemented rate limiting, you can learn valuable lessons and avoid common pitfalls. There are numerous tools and libraries available to help you implement rate limits, each with its own strengths and weaknesses. Gathering user feedback is crucial for adaptation, as users can provide insights into how rate limits affect their experience. Continuous improvement is key. As your service and its usage patterns change, your rate limiting strategy should evolve to meet new challenges. By staying informed and adaptable, you can implement rate limiting that effectively balances user experience with system reliability.
In conclusion, rate limiting is a vital tool in maintaining the reliability and integrity of microservices. We've explored various algorithms, implementation strategies, and best practices. By applying these techniques, you can protect your services from abuse, ensure fair usage, and maintain optimal performance. Remember that rate limiting is not a one-time implementation but an evolving strategy that requires continuous learning and adaptation. As you implement these concepts, we encourage you to share your experiences and feedback. Thank you for joining us today, and we look forward to seeing how you apply these strategies in your microservices architecture.